Good morning, student. Today we will see the application of a matrix to find the solution of the linear equation. To solve the linear equation, we have a different method, that is reduction method and the row transformation method or inversion method. Okay, so today we will see the inverse method to identify the values of x and y. In 10th standard, in 9th standard, we have studied the different method, that is graphical method, Cramer's rule, solve the simultaneous equation, substitution method to find the x and y. By using that method also you can identify, but in exam they will already specified using the concept of the matrix find the values of x and y. So that means we have to use the application of a matrix only, that is concept of the matrix, to find the equation. If you solve by that method you will not get the marks. So we'll solve this equation. So first in this equation we will convert this equation in terms of matrix. So you will write first matrix, that is the coefficient of x and y. Okay, here you will write x and y. This is for the understanding purpose, and this is your variable matrix, and this will become your constant matrix. Okay, so here you will write the coefficient of x, that is 1 and 2, and this is 1 and this is -1. This is x and y, and here you will write 10 and 5. Okay, now first we will identify the inverse of this matrix. So I will consider name this matrix as A, this as X matrix, and which is equal to C. Okay, so X is equal to, so we will use, that is A into A inverse. Let us see again, that is A into A inverse is equal to I. So we are writing A matrix and A inverse, which is equal to 1 0 0 1. So R2 tends to 2 times of R2 minus R1. So we are using this R2 tends R2 minus 2 R1. So we substitute this element, that is 2 minus 2 times of 1, this part, minus 1 and 2 times of this, we are getting this element, 0 minus 2 times of this, minus 2, 1 minus, you will get this matrix. Now we have to convert this element as 1. So R2 tends to R2 into minus 1 by 3. So I will multiply by minus 1. You divide by minus 3, so that will become 1. This will become 2 by 3. This is 2. And this will become minus 1 by 3. Next step, we have to convert this element as 0. So I will use this 1 to convert this as 0. So I am writing R1 tends to R1 minus R2. Okay, so A inverse, which is equal to, so we are changing R1, so I will writing the R2 matrix as it is, minus 1 by 3. This element is 1 and this will become 0. And this R2 minus R1, that is R1 minus 2 by 3, 1 minus 2 by 3, which will become 3 minus 2 by 3, which will give you 1 by 3. So this element is 1 by 3. Okay, again this is 0 minus 1 by 3, it will become 1 by 3. So this is 1 by 3. Now this is identity matrix, so I can write A inverse is equal to 1 by 3, 1 by 3, 2 by 3 and minus 1 by 3. Now this is the inverse of the matrix. Now this I will substitute in the equation 1 to identify the values of x and y. Okay, now this is equation 1. So in that equation we'll substitute A inverse and that C matrix from the question, and we'll identify the values of x. Now I will multiply this matrix. So this is 2 cross 2 and this is 2 cross 1. So we can multiply, because this element positions are same, the column of the first matrix should be equal to the row of the second matrix. This is same, so we can multiply this one. So I will multiply the matrix, so element, so 1, so this is 10 upon 3 plus 1 into this, so this is 5 upon 3. This element into this way, this is row and this is column. Similarly this into this, So 20 by 3, and this is my plus minus 5 by 3. Okay, now we solve this one, so the denominator is same, so I can club this one, so this will become 15 by 3, and this will become again 15 by 3. So you will get the answer as 3 5s are 15, so I can write 3 1s are 3, 3 5s are 5, and this is also 5. So we have x, y, which is equal to 5 and 5. So therefore x is equal to 5 and y is also 5. Okay, similarly this also you can cancel 3 1s are. So we have the solution of the linear equation by inverse method. Okay, that is similar steps that we have used in the previous class. First we have to convert this in terms of matrix, then you identify the inverse of this matrix after finding the inverse, that is by row transformation, or you can use the adjoint method if they will not specify, that is by using row only, so you can use the any method to identify the inverse. After finding the inverse of this matrix, you will substitute in the equation 1, that it means in this equation C is from this element and A inverse which we have already got here, and then you substitute, then multiply the following matrix, you will get the answer. Okay, to solve the linear equation by reduction method, that we will see in the next class. Okay, so kindly go through the video. If you are not understanding the concept, give the comment below so that I can get back to you. Thank you.